Hoisting is often described as the process of raising your variable and function declarations to the top of your code. So when you write something like this, where the cause variable is accessible by the console log before it's even declared, it gets interpreted by JavaScript more like this. For something like hoisting that feels pretty magical, there's a set of rules and limitations that we have to understand and follow. What's up, I'm Gemma, and in this video we're taking a technical look at hoisting. We're going to understand what it is, how it works for different variable and function declaration types, alongside learn how to use it to our advantage in our own applications. By the end of this video, you'll know how to use hoisting to your advantage, so you can further the functionality of your code by just how you simply organize it. So first things first, let's answer the big question of what hoisting is exactly. As I mentioned before, the term hoisting refers to the process of shifting or raising all of your variable and function declarations to the top of your code so you can actually access those variables and functions before they're technically declared. So it's important to note that when your code is getting hoisted, it isn't physically getting rearranged or shifted by JavaScript. Instead, JavaScript performs a double pass-through through your code, where the first pass-through, called the compile phase, is where JavaScript will scan through your code and look for all the variable and functions and figure out where in memory and which scope each variable and function should be accessible. This is when JavaScript will hoist all variable and function declarations to the top of the nearest scope. And the second phase is execution phase or runtime. So when JavaScript is executing your logic, it has all the values in the correct scope so it can perform all of the logic. So it's less of your code getting physically rearranged and more of your code just getting interpreted a little bit differently. So my explanation might have been a little too high level or arbitrary, so I'm going to walk you through a series of code blocks where we see hoisting in certain different cases. Before we jump into code blocks, there are two things that I want you to remember throughout this video about hoisting. The first thing is that your variable and function declarations will get hoisted during the compile phase to the top of your local scope. So before any of your code even executes, all of your variable and function declarations will be at the top of their respective scopes. And the second thing is that each variable and function declaration come with its own default value after being hoisted. And we're going to walk through each of these default values through the series of code blocks. So first up is the var variable. Let's take a closer look at the example that I showed in the opener of this video. So here I'm referencing the cause variable inside of my console log before cause is even declared or initialized. But since variable declarations get hoisted, and in our case our variable declaration is var cause, the following code block will actually get interpreted as the following. The cause variable declaration, which is again var cause, gets detached from its value initialization and hoisted to the top of its local scope, which is the top of our file. The default value of our uninitialized var variable is undefined. So when we run this code, the print statement will actually say undefined since we are printing out our uninitialized var variable. So the way that var variables get hoisted to the top of its local scope with an undefined value opens up a lot of interesting possibilities. Even though it gets initialized with an undefined value, the var variable is still being hoisted to the top of the scope. So what this means is that we could technically assign a value to a variable that hasn't been declared yet. So in this next code block, I'm going to show you how we can do that. So here I have my method mention cause, and inside you can see that I'm initializing the value of our cause variable before I've actually technically declared it. This is totally valid since JavaScript will hoist all of our variable declarations to the top of its local scope before code execution. So this code block will get interpreted as something like this, where we see that we have our var cause assigned to undefined and then it's getting assigned to our Black Lives Matter string. And then after that, we can print it out. This is pretty funky stuff and arguably not best practice when it comes to dealing with hoisting or variable initialization, but for the sake of this video and to show you how hoisting works, it's pretty interesting that you have access to something that hasn't been technically declared yet. Cool, so now we got var, let's move over to function declarations. It's super important to note that hoisting only works for variable and function declarations. It doesn't apply to function expressions. So if you have any confusion about function declarations versus function expressions, I've got you in this next code block. Here our hoisted function is a function declaration because the function had to be created with a name associated with it. It's impossible to use function declarations without including a name. Our not hoisted variable is actually being assigned to a function expression. The function expression itself starts with the function keyword and ends with the curly braces. So notice how there's no name associated with the function expression. Both function declarations and function expressions can be assigned to other variables, but it's a rule that function expressions can't be the beginning of a statement, meaning that they usually have to be assigned to a variable. So if we have something like function hoisted, this is completely okay because we've declared a function and initialized its value. But if we try to just have a function expression as its own statement, we're going to throw syntax error. Now that we've covered the difference between the two, let's look at hoisting for function declarations. So here, I'm able to call my hoisted method before I declared it, and then below it, I then declare hoisted, where I have a console log stating hoisted. With function declarations, the default value is always the function itself, since function declarations couple the action of declaring and initializing a value. So this code block would kind of get interpreted by JavaScript like this, where we first establish the declaration and initialization of our hoisted function, and then we call the function. Function declarations provide the most flexibility when it comes to hoisting because their default value is the value that you typically want and expect. For the sake of learning more about hoisting, let's check out an example that uses function expressions. So here you can see that I'm assigning my var variable not hoisted to a function expression. Again, var variable declarations do get hoisted, but their default value is undefined. So when we print out the reference to our not hoisted variable, it's undefined since we can't bring our function expression initialization along for hoisting. The way this code block is getting interpreted by JavaScript would look something like this, where we have our not hoisted var variable assigned to undefined, and then we try to print it out where we get the undefined value, and then right below that, we then initialize not hoisted with our function expression. So this example is a good reminder that function and variable declarations only get hoisted and not initializations. Alright, so we've seen var variables and function declarations, but what about the loved let and const? How do they work? Unfortunately, they're kind of weird in comparison. So in this code block, you can see that I'm trying to print out the variables cause and year before I've declared and initialized them. Unexpectedly though, we're getting an error saying that these variables aren't defined. So let and const variables do still get hoisted just like var variables and function declarations, but unlike var variables and function declarations, let and const never get initialized with any value. They do get hoisted, but it's not until runtime when they get initialized with their appropriate values. So this ultimately means that you can't access these variables before they're declared during runtime. And this inability to access let and const variables before they're declared is commonly referred to as the temporal dead zone. So the temporal dead zone is the region that exists up until we finally initialize let and const variables where we're unable to refer or reference to those let and const variables. So let's take a look at a code block to make this a little bit more clear. So you can see in the code block that we're in the temporal dead zone for cause and year up until we initialize their value. But since we're in the temporal dead zone when accessing those variables, we're going to get an error. I linked some really helpful articles and resources down in the description box, so if you want to do a little bit more reading on the temporal dead zone, you have those links down below. So we've ran through a number of examples where we've looked at different function declaration and variable declaration types with hoisting. But now you might be asking yourself, why even use hoisting if it's so all over the place, or when is the best time to use hoisting? So to be honest, hoisting is one of those concepts that if you don't have a solid grasp on how to use it, you can actually hurt yourself in the long run. That's why you've probably been told at a very early stage of your JavaScript journey to use let and const over var variables. Despite there being a chance of you throwing a number of errors by prematurely using hoisting, there is one foolproof aspect of hoisting. You can never go wrong with taking advantage of hoisting with function declarations since its default value is always going to be the value of the function. There's no chance of there being a reference error or an uninitialized error at any point when you're dealing with hoisting in your code. So what that means is that within any given scope, we have the ability to reference functions despite the order in which they were created. So I'm going to show you this in the next couple of code blocks. So here I have a code block with two methods, first util and second util. Inside my first util method, I call second util. So after our first function declaration, I call first util, which is actually getting called before I even declare second util. But since all function declarations get hoisted to the top, we're all good. But let's say that I wanted to get a function expression in the mix of all this. How would that work? So with this new code block, I updated my second util method that will call third util, which is a const variable assigned to a function expression, meaning that it's not going to get hoisted with its initial value. So when I call first util, that's going to call second util, which is now going to call third util. But we're calling third util, which has been initialized with the undefined value. So we're going to get a reference error thrown saying that third util has not been initialized. So function declarations allow us to disregard the order in which they're created. As long as we're in the appropriate scope, we're able to reference function declarations regardless of the order. So hoisting is a super powerful feature in JavaScript that allows you to compose your code a little bit out of order. There are some examples of hoisting that you probably wouldn't want to do, like assigning a value to a non-declared var variable, but there are other cases where you do want to take advantage of hoisting, like function declarations. But all this can be pretty confusing, especially if you're still trying to get a better handle on lexical scope or even block scope. So my recommendation is, if you want to start taking advantage of hoisting in your applications right now, start thinking about using function declarations over function expressions. That's it for this video. If you made it this far, thank you so much. I really do appreciate it. If you want to see more videos on hoisting, let me know down in the comment section below. If you enjoyed this video, please drop a like and subscribe to the channel for more JavaScript content. I'm also on Twitter, where I talk about JavaScript and a whole variety of different things. You can send me a DM and we can have a chat. And with that, I will see you on the next video.